Hello and welcome to my channel. Today's video is going to be how I created this piston assembly here, how I designed it using the part design workbench, and how I positioned it. Now I made this video to follow along with my additive cylinder video. Actually, it's in the reverse order. When I made this, I decided it'd be a good idea to make a additive cylinder video. And then also I'd like to make a Tinkercad versus FreeCAD video and do a piston design and position. So to do this video, if you want to go grab the drawing document, it's a PDF and it's on my website at mathcodeprint.com, and I'll leave a link in the description. And it's here. So this has the same dimensions that I'm going to use in this video, except I need to add this right here to be 70 millimeters up. So feel free to grab that. And then also I'd like you to think about heading on over to Patreon. I'm at mathcodeprint.com, and so you can help me out and support me in these video endeavors. And look at that. So to start, we'll do the piston, and I'll just do a body, and we'll use our additive cylinder. So our radius is going to be 50 millimeters, and one thing I like is to bring that right in the center and go to the corner like that. So you can use this, or you can click right there. And let's make the height 100 millimeters. Get that back in, back zoomed the way I like it. And we'll just leave that not attached because that's just going to be sitting out there. And to hollow out the center, I'm going to select that top face, and we're going to make a thickness out of a solid, or a thick solid, or whatever it is. And we don't want it to have, we don't want it to be going outward because that would add thickness. And if you look, you can see that it adds a fillet, or a corner there, and I don't want that. I don't want it to be as if it was machined. So if we make it inward, that goes away, and it's the direction we want. Based on our drawing, we want it to be 5 millimeters, and we can click OK, and we're done. So the next thing we want to add is, or subtract rather, is where the wrist pin's going to go. So I'm going to start out with a cylinder, and again, I like to do this. So our radius is going to be 9.9, and that's just so that it looks like there's a clearance, but that would be a terrible clearance for that. And it's going to be 100 millimeters. So you'll notice that the attachment is already ready for selection for the first attachment. So I'm going to pick the XZ plane so that it's attached in that orientation. And then I'm going to offset it in the Y, because now our Z is pointing off of the XZ plane, so the local Z. So I'm going to move it in the Y direction, and that's just going to be up at 70, because that's what I picked for the wrist pin location for no particular reason. And then in the Z direction, I'm going to move it back 50, not 500, 50, so it's centered. And I wish there was an easy way to attach in the center of the object and not just on the origin. But anyway, there are ways to do it, but not easy in the way I would like. The final thing is we're going to do the cutouts for the rings. So I'm going to do that with a sketch, and what we're going to do is we're going to draw four squares, and then we'll zoom up and we'll manipulate these. Oops, didn't mean to exit the sketch. So what we'll do is I'll select these three sides, and we'll make those equal, and then we'll make the horizontals equal. And then I'll pick a corner vertex on these and give them a vertical constraint. So now they're all in line. And now let's set the size for this. And these are going to be, let's make these 3.5 millimeters deep. I don't know what they should be, but. And then each one's going to be 3 millimeters high. Actually, let's make them 5 millimeters deep. 3.5 sounds too small. As if I know. And then finally, we're gonna give them a gap between the rings of 8 millimeters. So 5 is from my drawing, so we should use that. And I'll set this gap here to 8. And then finally, we're gonna set this. Oh no, I'm sorry. These are 5. Wasn't thinking straight there. Because that's 3, 5, and then this is gonna be 8. And again, these are just numbers I picked out of my head because they don't really mean anything. So now I'm going to slide this over closer, because sometimes if you do, like I do a measurement constraint, it pulls this line to the other side of the sketch, and I don't want that. So I'm going to get it close to where I want it so it doesn't have the chance to do that. And we're going to set that right at 50. So now that's a fully constrained sketch, and I'm going to revolve that with a groove, a subtractive groove. Or so to revolve, so subtractive revolve, and they call it a groove. So, and that's, let's see, it shouldn't be reversed. And so we did something wrong because it shouldn't be getting rid of the whole thing. Let me see if I can figure out what I did wrong there. So our cylinder is 50 millimeters, and our sketch is, let's try making this 49 just to see what. Oh, let's look inside. Oh, I understand what I did. This it's just basically removing the whole thing, and you can only have one contiguous solid, so it just basically chopped off the top. So let's make this 4. Oh, and I didn't actually have a measurement in the PDF yet, so we'll do that 3.5. Good. Sorry about that. So now we have our grooves. So what was happening is the groove was, as thick as the wall, so it was lopping off the top. In part design, you're designing one contiguous part. So because it cut all the way through, we had 1, 2, 3, 4 parts instead of 1. So it only wants one at a time. That's an important thing to remember for part design. It can be frustrating if you don't realize that. So that's our piston. So let's name that our piston. And now let's create our wrist pin. This will be the easiest one. So the wrist pin is just going to be a body with a additive cylinder, and it's going to be 9.9 because we want it a little bit tinier than the thing, but it would really be 9.95 or 96 or something. So that's a bogus tolerance. And again, we're going to pick the same thing to get it in the right position. Now, as this is just going to be a part, we're just going to leave it right there for now. Let's call that wrist pin, because we're going to use draft clones to position it. And these are going to be parts, sort of our parts database. So let's do our reposition. Okay, so now let's do our crank rod. I think that's what you should call it. So this is going to be a sketch because to me that was the most straightforward way to make this. And this is just a real simple sort of thing. It's not not official or anything like that. So I'm going to get rid of those for now. And it's going to be two. These will be the openings for the rod, and then these will be the ends. So I'm going to be doing an arc segment here, one there and one there, and then these will be connected by lines, and we'll just give these vertical constraints to keep them in line with each other. One there and one there, and then to keep these basically this, if we give these horizontal constraints, it basically keeps that wall constrained. You don't have to do a symmetry constraint or anything like that. So now let's give these the radiuses. So this is going to be, what's this one, 10, and then this one will be, let's see, that's going to be 15, and I just went on what it looked like is all. So I'm not basing this on anything real. So this is going to be 16, and this is going to be 27. So again, just what it looked like. So that's our basis. And all right. So to get it fully constrained, we just need to add a distance for this one. And I think that was 15. Okay. So wait, not fully constrained. Oh yeah, one last thing. So basically, this is we got to add the rod length, so that's pretty important. So that's going to be 100. And there we go. Now we're fully constrained. So that means that nothing can move. And let's close the sketch, and then we're just going to pad it. And we'll just 10 is good, so we'll just leave it at that. And we've got our rod. So good to go. Let's call this our rod, and then we'll be done. And now let's do our crank. So we'll do a new body, and let's hide the rod, and we're just going to do yet another cylinder, and this will have a radius of 50. And again, I'm going to bring that out, and it's going to have a height of 10 is good, and we will put it on the XY plane. Now this one I'm going to have it go flip sides, and let's go to the right so you can see what happens. When I flip sides, it just goes to the other side of whatever you have it attached to. So that's good. And now we're going to add one more cylinder to it. That's going to be the crank, the cam lobe. So do cylinder, and the cam lobe is going to be 16. And again, we'll attach it here. And then it's going to have an offset of 35, I think I did. Let's try that. I thought that was on my thing. So again, so Z is coming out this direction now, local to the cylinder because we turned it. So I'm going to move it in the X direction, I think. Yep, 35, which you could do Y too, but so 35 brings us right to the edge. So that's a reasonable cam for us, reasonable looking thing, and that's it for the crank lobe, crank and cam lobe or whatever. That's it. So we have our four things. Let's call this cam. All right, and then as I mentioned before, this is sort of our, I call it a part pile often. So I'm going to just make a folder here, and I'm going to call it parts. Now I tried some of this with using the part container, but I couldn't get the result the way I liked. It made it a little bit too cumbersome for me. But you definitely should check this part container out. It's had some improvements, especially if you're in 1.9. It's gotten even better. So now what I'm going to do is I'm going to create clones of these, but we're going to use the draft clone. And the reason I'm using the draft clone is it has an attachment, so you can do map mode for a draft clone where you can't do that for the part clone, as far as I know. So now I'm going to hide these. I had to hit that space twice, but you still see I have these. Okay, and I'm going to make another folder. I'm going to call this assembly. Okay, and just put all of these in the assembly folder. Now to position these, I'm going to make a sketch. So let's hide this. And the first time through, to get it synced, you have to hit space like 3 times. So let's go to the front. But my sketch is going to be just in the Sketch Workbench. It's not going to be Part Design Workbench. So it's a free floating sketch. So with nothing selected, I don't have anything selected. I'm going to put it on the XZ plane because that's what we've been working on. Sorry, I choked a little bit there. And all I need is a triangle. So I'm going to use the polyline tool, and I'm going to leave these 2 points are going to be constrained to that center line, and I'm going to get a fully connected triangle. I want to make sure of that so I don't get any funny results. And then I want to make this the rod length, so that's the same as the rod length. And this is going to be the same as the cam offset, which was 35 if you remember. I'm going to leave it at, let's set this at 90 degrees so we can get, so it's just easy to work with. You can see how it wasn't. And then we're going to put our cam up at 170. So what's going to happen is at this point of the sketch is going to be the center of our cam. So let's close that sketch and let's bring it into view. Oops, this time I don't want that. Let's do front because I'm positioning. And let's show our assembly again. So I'm only going to work with one at a time, so I'm going to hide the rod, the piston, the wrist pin. We're going to move the cam up to this point first. So with it selected, and you can either have the whole thing selected or just a face. I'm going to select move, and then I'm going to make sure that I get the center, the center snap, and you can see that with the aqua circle with a dot in the middle. So I've got the center snapped, and you can see that the line indicates that that's where I've snapped to, and I'm going to select this line, and you'll see I get the endpoint snap icon there, and I'm good to go. So now it should be where I want it. I'm going to double check this, make sure it's not, so I've been getting this weird 0.392 offset. I don't know why, so let's get rid of that. Maybe it was there before I did it. So now that's correctly centered. And let's move the rod next. So let's bring the rod up, and I'll select the face there, and we'll do a move. And you can get that center select with a couple of different ways. So for this one, I want that line, and we'll center it there, and that's good. And now I'm going to rotate this by using the draft rotate tool, and we just want that white dot in the center. It doesn't matter because it's the center of rotation at this point. And let's pick, oops, I did that wrong. Let me escape out of that. Try it again. Rotate. Center of rotation is going to be there and there. So now I can just rotate it to get to the end point, and you can see it's able to snap to that end point. So now one thing I can do to check is, I know that this rod from center to center is 100, so it should be 100 from there to there. To measure that, I want to get my draft plane back, and I want it to be on top of here. So that is, let's just double check that. Yep. So, and I want to snap to the plane. So now I'm going to do a measurement. So from the top of this to directly over that, so it's not going to be on the dot, it should be 100. And that's good. So now I know that this is positioned correctly and my rod is positioned correctly. Now let's see if I can move my wrist pin. So let's bring the wrist pin up, and let's do a move and center select, or center snap and center snap. And it's not in its final position, but it's close. So we'll move the we'll move the piston. So finally I want to move the piston here. So I'm going to select the face, and one of the things about selecting just the face is you'll be able to, you can see things a little bit better, especially if you select the face that you're not going to use for a snap selection later. So let me see if I can show you what I mean. So I want to get the center of this cylinder here. So you can see, yeah, so I can, it's the center offset on the plane. You can see the white dot there. And I'm going to center it to here, and that's good. And because I have it snapped to plane, it didn't move any in the Z direction. It only moved in the XY direction. So my piston, it should be exactly where I need it. Let's do that, and let's turn off the grid. And it looks pretty good. Everything looks pretty well lined up. Sometimes you can check things by highlighting, and then, yep, I can't see any of that, so that's good. So the only thing left to do is move my wrist pin in, and I should be able to do that just by transforming it 50. And yeah, so that's it. That's our piston in position. So basically, however you set this sketch triangle, you can position, it makes it easy to position this rod against that triangle line, because the triangle is the same dimensions as the triangle set by the cam, rod, and throw, total throw relationship there. And actually we could even go further to use that sketch to animate it, and maybe I'll do that in another video. Let me know in the comments if you'd like to see that, and thank you for watching, and stay tuned for CAD battle, Tinkercad versus FreeCAD, and I'll tell you right away that FreeCAD will win because I'm partial. Have a nice day. Make sure you subscribe and click the alarm bell, and I'll see you next video.